For this video, I'm going to talk about the YouTube Homework 2 HR92 kinematic problem with data table. In this question have already provided the post number and distance travel in meters and also time required in seconds. So for question A, I'm going to use Excel to make a graph which have already show the relation between the distance and the time traveled. For answer A, I have already insert the time in seconds and also the data in meters, and also this is the graph which is the relationship between the times and distance. It looks like a curve, so obviously it is very hard to find out the accelerations of overall travel process. Then for B, I use the data of the table and graph D versus T square. So for times, then I use time square is for 0 is 0 at the time of 1.63 I got 2.6569, and then for 2.33 I got 5.4289, and then for 2.83 second square is 8.0089 second square, and then for 3.31, and then I got a second, and then I got 10.9561 second square, and then for 3.79 second, and then I got 4.3641 second square. And then for this I find out a very strict line of the relationship of time squared and distance, and then for x-axis it represents the time square, and then for y-axis it represents the distance. Then I find out the linear equation is y is equal to 3.5169x plus 0.7246. Then x is represent the time square, and then y is represent the distance. For my calculation for it, there is equations, and there is a formula that I learned in the class is distance the total distance is equal to x0 plus velocities x0 and times and then plus 1/2 accelerations and then time square. And finally I got for distance is 1/2 accelerations times square. And then from the graph that I got is distance is equal to 3.5169 times squares plus 0.7246. So distance is equal to distance, so I make an equation is 1/2 acceleration times 2 and then equal to 3.5169 times square plus 0.97246. And then I let overall time travels is 50 seconds, and then I plot in this equation that I got. Acceleration is 7.03437.968 meter over second squares, which I round to 4 significant figure, and then I got 7.034 meter over second square. Then I use these accelerations to calculate the particle velocity. So for the particle velocity, which is at 1.63 seconds, I use the velocity pose number 2 is equal to velocity initial velocity plus accelerations times 1.63 seconds, that I got 11.5 meter per second. So I use the same way to figure out all the particle velocity. So at 2.33 seconds, I got the velocity is 16.4 meter seconds. And then at the 2.83 seconds, I got 19.9 meter seconds. And then at 3.31 seconds, I got 23 meter per second. And then at 3.79 seconds, I got 26.7 meter seconds. So I also plot in the particle velocities into this plot. Okay. Thank you for listening. This is all the words I done. Thank you.